Hello again. Today we're going to finish up a good part of chapter two. Maybe we'll finish the whole thing. We'll see how far I can get. I'd like to spend a little bit of less time with a lesson. Maybe keep the lesson a little bit shorter and let you guys have some more time doing some of the hands-on labs. I think we're finally getting far enough along in the material where you can do some labs that are a little bit more advanced. Okay. All right. So we left off last time speaking about some of the primitive data types. Today I want to show you a couple more. We're going to talk a little bit about the primitive data types for floating point values and Boolean values. So a floating point value is any kind of value that can store a fractional part of a number. All right, so for example, the number pi, right, 3.14. That's something that you could store in a floating point number. And again, remember, integer values are things that are whole numbers. Okay, there's two general floating point types. The first one is called a double, and the second one is called a float. Okay, the way that we can declare and initialize a value that is a floating point value is as simple as this. I can say double. Notice you'll see it comes up in blue. I'm going to create three different variables here that are all going to represent some kind of like an interest rate or something like that. First one I'm just going to call D rate, okay, meaning that it's the interest rate stored as a double. And so I'm going to declare D rate and initialize it with the value of, I don't know, 4.5. All right. Another type of floating point value that we can use is what's called a float. And a float is typically smaller than a double. On a PC, I believe a double will consume 8 bytes and a floating point value will consume 4 bytes. Did I say that right? A double should consume 8 bytes and a floating point value will consume 4 bytes. So you get a little bit less precision in the floating point value. I believe the general rule is that it's actually compiler specific and operating system specific. But you're guaranteed that a double will be at least the same size, if not greater, than a floating point value. That's the general rule. So let me declare another variable of type float now. Again, you'll notice it's in blue, and this time I'm going to call it f rate. And here I'm going to assign f rate the same amount, which is going to be 4.5. And what happens is we're going to get a compiler warning in a little bit, or at least we should. The reason is because the default behavior of a floating point literal, meaning the number that I typed here, 4.5, the compiler will interpret that as a double. So what happens here, the thing on the right side of the assignment operator is going to be a double. We're then going to assign it to something that's a floating point value, and we may experience some truncation. So the compiler will show us a warning, and I'll show you how we can fix that in a minute. Last thing is, again, I mentioned to this in the previous lesson that if I create a variable that's of type integer, and I'm going to call this irate, and I assign it a value of 4.5, the compiler will once again let us do that. However, remember what's on the right hand side of the assignment operator is a double. In order to get that into an integer called irate, the compiler is going to have to convert 4.5 to a integer. And essentially what it will do is do truncation, and it'll strip off the 0.5, so it'll stick the value of 4 in irate. Once we have these variables declared and initialized, you're free to use them as you would any other type of variable. You can use these in mathematical expressions. You can use these for whatever purpose. Real quick, let me just show you if I display what these guys look like. So I'm going to do a quick C out here. Insert Endel. Copy paste this down. All right. D rate, float rate, I rate. Oops, forgot one thing, the important part. All right, D rate. Down here, my variable F rate. And then lastly, the I rate. Okay. When I do this, it will display each one of the values, okay, stored in each of those three variables. When I go ahead and build this, I should get at least one compiler warning, possible loss of data, and that's this here. Okay, so what's happening is the compiler is telling us that this may or may not work as you expect, and it's trying to convert a double to an integer. Possible loss of data. In this case here, we're all going to lose data because we're going to be truncating the 0.5. Another thing is, depending upon the compiler that you're using, more often than not, what will happen is you'll actually get a warning if you have a floating point value being assigned a literal number. For example, this case here, 4.5. The reason is because a double is probably going to consume more space. If your compiler gives you a warning, one way to turn that warning off, okay, is if you just put an F after the floating point literal. The compiler will then take this value here and actually convert it to a float. As you can see, if I hover over this right now it's telling me that it's a float of 4.5. If I hover over here, up here, you'll see that it's actually treating that as a double. All right, so if your compiler complains about that, just throw either a lowercase, or you can even use an uppercase F after the 4.5. So not U rate, it's I rate. Sorry, wouldn't have mattered anyway, but all right. So this warning down here that I'm getting, for all intents and purposes right now, I can ignore it because I'm just using this for demonstration purposes, just to show you what's going to happen. So now when I run this thing, you'll see what happens is the value for D rate, the value for D rate will be assigned 4.5. The value for F rate will be assigned 4.5, and the value for I rate will now just be equal to 4 because it truncates. It doesn't do rounding, so don't think that this is going to round it up to 5. It literally just does truncation of the value. So that's it. That's pretty much it for the numerical data types that we're going to be using in C++. If you work with C or Java, the data types are pretty much the same. And so that's it. Those are our numerical data types. We have different types of ints and different types of floats. Now I want to talk about a different type of data type that is not one of the primitive data types, and that is what's referred to as the string data type. So just as we have in the past, we've used numerical literals within our program, we can also have integers or doubles act as variables within our program to act upon those literals. Well, quite often we'll do things like this in our program where we hard code a string. So this is what's called a string literal. Quite often you're going to want to assign that string literal into what's called a string object, and perhaps perform some manipulation on that string object, or you might need to append that string to another string, and those types of things. So what we need to do is, again, this is the first data type that we're going to see that is not one of the primitive data types. It's actually what's called a class data type or an object data type. And in order for us to use strings in our program, we need to include another library. We need to include another header file. The name of that header file is called string. So what I need to do here is do pound include, and this time here it's just going to be string, not string.h, just string. I think if you import string.h you'll get the same behavior, but we're going to use a standard library, so we're just going to import string. That means that when I do this include right here, I can then go ahead and use all the things that are part of the string library. How do we create strings? Well, it's very similar to what we've done in the past with our primitive data types. All right, so look, let me show you a little example here real quick. So I'm going to create a string variable. So it's type string. Oh, notice it's all lowercase. And I'm going to call it, I don't know, call it my string. And I'm going to declare it and initialize it with a value hello. End of a statement, semicolon. Now that the string literal hello will now be assigned to the string variable called myString, and now what happens is myString is technically what's called an object in my program. since it's an object in my program, I'm free to use any of the methods that belong to that object to perform whatever task that I want to do. One of the things that I want to do right now is just show you that with strings, some of the simple things that you can do is append one string to another. You can determine what the length of a string is. So let's say, for example, I want to append something to the end of my string here. You can use the mathematical plus operator, which will allow you to perform what's called string concatenation. So what I could do is I can just type my string is going to equal to my string plus, okay, and I'm just going to say class, whatever. All right. Now my string is going to be referring to internally it's going to be referring to the string my class. Now what I can do is I can do things like, my string equals my string and L. So you notice here, when I want to use the variable my string, I don't enclose it within quotes because I just want to access the contents of the my string variable. I can go ahead and build this now. Let's run it. You'll see what happens. There's nothing terribly fancy here, but you'll get an idea as to how strings can behave. So now my string is just equal to hello class. I can also do things on strings, and I can invoke some of the functions or methods that belong to my string. One of the properties, or one of the methods I can invoke, is there's a length method. So you can query a string and ask it things like, what's the length of the string? Does the string contain a certain word, or does it contain a special character? Take the string and convert it to uppercase. Take that string and convert it to lowercase. All those types of things. So for now, what I want to do is I want you to capture what is the length of my string. Okay. I'll just call it len for length. And what I can do is I can invoke the method. Well, what I do is I need to access the object, which is called my string, and then once you hit the dot, you'll notice that a whole bunch of methods pop up, like or things that you can call on this object. One of the things that I'm going to do, well, the thing that I'm going to do now is just calculate what is the length of the string. Tab away here. This is a function on the string class. So I need to append a pair of parentheses after the dot length. And oops, I'm sorry. Now what I'm going to do is I'm just going to capture this statement and store the results in the length variable. Now what I'm going to do is just display what the length is of my string. So here I'm going to just say, oh, my string length equals len. Remember, len is an integer in this case here. And now I'm going to build my program. I'm going to run it, and you can see that now it will, I can query the string and determine what the length is, and now that I know that the length of the string is equal to 11. So the length of this string includes the 1, 2, 3, 4, 5 letters for hello, a space, okay, remember there's a space here, and then the 5 letters for class. So the combination of those two, right, so 5 plus 1 plus 5, that gives you the length of 11. That's pretty much it for strings for now. We're going to talk a lot more about strings later on, and how we can use strings to capture keyboard input and store variables from our console into a string, and do some other types of string manipulation later on in the semester. But for now, that's pretty much it for strings. Next thing I want to do is talk about the last primitive data type that we're going to cover in this class, and that's what's called the bool data type. All right, those of you may be familiar with the term bool or boolean. Boolean is a type of variable that can contain one of two different things: the value true and the value false. All right, this is used all over the place in computer science, because quite often we use this for conditional logic where we'll do something and say, within our program, you know, if somebody's grade is greater than 70, then they get a pass, then their grade is a passing grade, or passing is equal to true. If their grade is less than 70, then passing is equal to false, something like that. So what we can do is we can use Boolean data types to capture something that's in one of two different states, which is either true or false. So let's do this. Let's I don't know. Let's create a little variable here. I'm just going to call it pass. Okay, and the variable bool can, the variable pass can only contain one of two different states, either true or false. All right. So here, let's just display what pass is equal to. I'm going to say cout pass equals, did it again, pass equals pass. Now what I'm going to do is, let me go over this real quick. I'm going to assign pass is going to now be equal to false. And now I'm going to show you that you can have true or false in this variable. If I run this, you'll see that the contents will actually display on the screen as 1 or 0. The reason is because in C and C++, the notion of true is essentially any value that's not 0, and the notion or the value for false will always be 0. So in this case here, which actually is going to display, is the value 1 or the value 0. So since something is true if it's anything other than 1, okay, I could go up here and say, all right, well, this should work with my compiler. Let's say, let me change, I don't know, pass to be equal to 5, right? If I run this again, it's going to give you some truncation. Let's see what the warning message is here. Okay, so it's converting from an int to bool. That's fine, because in this case here, 5 is anything other than 0, so that will still be treated as true. And you'll notice that what happens is when I run this, right now, pass is going to be equal to 1. Why? Because I assigned it something other than 0, so this now indicates the value of true. Typically, you won't do things like this. You won't assign numerical values to a bool variable. But what you will do is you'll do something like this where you can, assign either true or false. So the language is fairly flexible in this way, and it will permit you to assign, integer type values to a bool variable. Once again, let me point out here that bool shows up as blue. Why? Because again, that's a key word in the language, and that is an indication to you that it's a key word or a reserved word. One thing I want to mention to you also is a number of students will do something like what I'm going to show you in a minute, and this will appear as a compiler error on your behalf. So what happens is you can, if you want to assign something to a variable, the assignment operator will always go to the right of the variable name. It's never the other way around. So what I can do is what I can do is like what I have up here on the screen. But what I can't do is put a value on the left side of the assignment operator, meaning I can't reverse this. Okay, if I do, you're going to get some kind of compiler error, and this tells you that the expression must be a modifiable L value. L value just means the left value, meaning that the thing on the left-hand side of the assignment operator must be something that can accept the evaluation of an expression. All right, so this is backwards. I know this is not an uncommon thing for students to do, so just be aware of that. All right, next thing I want to cover is something that it will be used probably not so much in this course, but if you take the second half of this course, which is the Advanced Programming C++, there's sometimes we need to determine what the actual size is of a variable. What I mean by size is how many bytes does a variable consume. The reason is because what happens is sometimes we deal with something that's called pointers. Some of you may have heard what a pointer is, and there's a way for us to be able to use the size of a variable along with an array, and use the size of the variable to help us what's called iterate or process the elements within an array. You'll be exposed to this later on if you take the course, but nonetheless, I want to go ahead and at least cover how we can use this size of operator to determine the value of the size of a variable. So let me delete all this stuff here. I'll leave pass over here. That's fine. So there's an operator that's called size of. Kind of works like a function in C++, and what it does is you feed it either a literal or a variable, and it will determine how many bytes that variable or literal consumes. So let's go through a couple examples here. I don't think there's a table of this in the book, but you could go through and do this on any of the data types that we'll come across. So I'm going to call size of in a minute. So let's say let's figure out what the size is of an int. So the size of an int will be equal to, so remember what you see in red there is just the string. All right. Now what I want to do is I actually want to feed something into the insertion operator, which is going to calculate the size of an int. So what I can do here is I can just say size of. You'll notice this appears in blue. It's not really a keyword. It's an operator. So it's a slightly different shade of blue, but nonetheless. And what you need to do is pass to it either a literal or a integer. Either a literal or a variable, and then it will calculate how many bytes that variable or literal consumes. So in this case here, I'm going to feed it an integer. Let's do this for an int. I'll do it for a long, maybe for a float and double, and then I'll do it for a pass over here. So let me copy and paste this down. So we have the size of int. Let's see what the size of a long is. Again, if you're doing this on a different type of machine, again, I'm using a Windows machine running Windows 7, a 64-bit version of Windows 7. It's possible that, well, I don't think so, but I think on any kind of PC you'll always get the same results. But if you're using a Mac or a Linux machine, you might get different results than what we're going to see here in a minute. So there's int long. Let's try float and float. So the size of float, and let's do two more. All right. Size of double, and size of double. All right, and let's do one more that is actually a variable, and let's see what is the size of my variable pass. Right, I have a variable up here. Right, I have this variable up here defined called pass. It's of type bool, so let's see how big a bool or boolean data type is. So here what I'm doing, I'm not going to pass in the bool data type, but I'm actually going to pass in a variable. In this case here, it's just going to be pass. All right. One thing I want to point out to you also is that notice here that after my stream insertion operator, I'm not actually passing a variable or a literal. I'm actually passing something that is going to execute. What's going to execute here is the size of operator or the size of function, and it's going to return some value. The point I'm trying to make is that you can have things within your cout stream that will evaluate to some value, and that will be done at runtime. The point I'm trying to make is that you don't need to capture the size of the int somewhere outside of your cout statement. I mean, you don't need to do this. I don't need to say int, size of int is equal to size of int. Okay, you could do this, and then you could take this variable here, size of int, and replace it with what we have over here, and you would get the same result. It's not necessary to do that. It's quite often that you will want to do shortcuts like this just to keep your code a little bit cleaner. All right, so that's could be done that way, but it's not necessary. So let me build this thing and execute it. Let me see what my results are, and then you can match them against yours, and I would imagine you're probably going to get the same results. All right, so on my machine, right, the size of an int and the size of a long are both 4 bytes. That I'm kind of surprised about. I figured a long would be 8 bytes, but nonetheless, that's the size. That's how many bytes a int and a long consume in my machine. A float and a double. All right, so a float consumes 4 bytes, a double consumes 8 bytes, and this again follows the rule with the language is that a double will be at least the same size, if not larger than a float. So in this case here, it's larger than a float. And the last one, which is the size of pass, right, which is a variable, okay, of type boolean, of type bool, the size of that is just equal to 1 byte. Reason why that's just equal to 1 byte is you can think about, this is just a switch, right? It's either on or off, so you don't really need a lot of space to store something that's going to be in either one of 2 different states. 1 byte, more than enough. So that's it for the size of operator. Don't worry about this so much for this semester. If you take the advanced class, you'll be using this for what's called a pointer arithmetic. Okay. Let's see. All right, now I want to talk a little bit about some of the arithmetic operators that are part of the language. There's basically 3 different classification of operators in the C++ language, and the author summarizes here rather nicely. This is about page 62 in our book. Actually, I think this is slightly off. Actually, maybe either page 61 or 62 for you. All right, so there's 3 different types of operators. They fall into either a unary bucket, the binary bucket, or the ternary bucket. Each one of these operators determine, or the type of operator determines how many what called operands the operator has. So something that is a unary operator is something that only takes 1 operand. Something that is a binary operator, which is the most common one, that's one that we're going to see in a little bit, that's something that takes 2 operands. And the last one is what's called a ternary operator, and this operator here actually takes 3 operands, and there's only 1 ternary operator that I can think of. We're going to cover that in this class, and it's something that's super useful, and we'll talk about that later when we work with conditional logic. So let me scroll down a little bit and show you the core mathematical or arithmetic operators. They're pretty self-explanatory. So if you want to do addition, you use the plus sign. If you want to do subtraction, you use the negative sign. If you want to do multiplication, you don't use X, but you use the asterisk. If you want to do division, you use a /. And if you want to do what's called modulus arithmetic, which is when you want to calculate the value of a remainder. So if you're doing division, you just want to calculate the value of a remainder, you would use the %, which is what's referred to as a modulus operator. And you'll notice here that each one of these are the type binary, meaning that each one of these operators over here requires you have 2 operands. Let's take a look at what the author has here for an example. We'll do on our own in a little bit. So here's a variable that's called total. Let's assume this was declared in somewhere else in our program, and you have 2 other variables over here, cost and tax. Again, let's assume that those were declared somewhere else in our program. And what they're doing is they're using the addition operator to assign the summation of this variable and this variable, and then assign it to this variable total over here. So you'll notice that the plus sign actually has what's called 2 operands. Cost is 1 operand, and tax is the other operand. And you'll see that the other operators down here, such as subtraction, multiplication, division, and modulus, each one of them has 2 operands. So let's do an example on our own. Let's do an example together here real quick, and I'll show you how these work, and I'll also show you how what will happen if you do division with integers, which is slightly different than doing division with double. So let's just do a couple little examples here. So let me flip back to my IDE, and what I'm going to do here is I'm just going to create a I don't know, I'll create a little variable that's called an integer variable that's called sum. So I declare it over here, and then I'm going to initialize it the product. Oh, I'm sorry, I'm going to initialize it to the expression of 10 plus 20. All right, nothing really complicated there. So again, here's my arithmetic operator. I'm going to take 10 plus 20, add those two together, and then I'm going to assign the result to sum. Let's create another one real quick. I'm going to make another integer. I'll call this product. And this is going to be equal to, I don't know, 5 times 20. All right, so when that gets evaluated, right, it's going to multiply 5 times 20, and it's going to assign it to product, which will be 100. One thing I want to point out to you also is that I did this a second ago, and I tabbed away. Remember, the compiler doesn't care about white space. Okay, the typical convention is that you put white space in your program just to make things easier for you to read. So for me, this is just a habit. This is the way that I like to do, spread up space, put some space in between my variables and my literals. You don't have to do that, okay? I mean, it's completely fine as far as the compiler is concerned to do this, okay? They're both equivalent, okay? I just prefer to have a little bit of space in there because I think it's easier to read. All right, let's do, let me do some division here. All right, so I'm going to create a variable called int, and I'll call this div. I'll do two of them, div1, and I'm going to make that equal to 12 divided by, so I'm going to do division here, 12 divided by 5. Let's see what happens when this executes, and I'm going to do another one. In this case here, let me do a double, and I'm going to call this div2, and you'll see the difference in behavior in a little bit. And here I'm going to do 10.0, right? So that is a assignment. Sorry, 10.0, right? So that's a double divided by let's just do, I don't know, 2.5. Okay, that works. All right. That's good enough for now. Let's go through these. So I did. All right, let's do real quick. Let's do subtraction. I think we all know how to do this. So we'll do int subtract, and I'm going to make that equal to, I don't know, 5 minus 2. Right? So we have addition, subtraction, multiplication, and two forms of division. All right, let's see what we get here. All right, so if I do cout sum equals sum. All right, let's do this for the rest of them. I'm going to do copy paste. So we have sum product my subtraction. What else we have? Division1. Remember, this is integer. And then I'm going to display div2, which is a floating point division. And let's display div2. All right. Actually, let me change the order of these real quick, and you'll see why in a second when I go to build this thing. All right, so let me build it. Shouldn't get any warnings here. All right, that looks good. Let me execute this thing. Let's look at the results, and I think you're going to see something that looks a little bit strange. All right. So here are my results. All right. So the sum is equal to 30. Right. That's pretty straightforward. 10 plus 20 is equal to 30. That's an integer. We stick it in an integer. Fine. Next one, product. Right. 5 times 20 is 100. Those are two integers. Multiply them together. Store them in product. We get 100. subtraction, 5 minus 2 is equal to 3. It's an integer. We stick it in sub, which is an integer. That works. All right. Let's look at the next one. So actually, the order that I have here is okay, now here I'm displaying div2 before div1. This is what I'm trying to illustrate here. So div2, all right, div2 is taking 10.0, oops, I lost my screen, 10.0 divided by 2.5. That's going to be equal to 4, right, because 2.5 goes into 10 exactly 4 times. Makes sense? But let's look at the next one, which is called div1. This is when you do division with integers, you get what's probably an unexpected behavior in terms of what you would probably expect. So if I took 12 divided by 5, well, 12 divided by 5 should be equal to what? 2.4, right? But why am I only getting 2, right? I'm only getting 2. It's not 2.4. The reason is because when you're doing division and you have two operands that are both integers, the evaluation of that will be doing what's called integer division, and integer division truncates or strips off the remainder, right? So 12 divided by 5 is equal to 2 with a remainder of 2. All right. So what gets truncated is the 2. Let's make this, I don't know, let me make this 13 divided by 5, right? So that should now be equal to, it'll still be equal to 2, but you would think it would be 2 remainder 3 or perhaps 2.6. And let me change this to be 13.0 divided by 5.0. And let's see the difference. I gotta kill this window quick. Let's see what the difference is in the results here. So if I run this, all right. So my double division, right, which is a 13.0 divided by 5.0, that evaluates to 2.6, right? That's what we would expect. This guy down here, my integer division, right, I'm doing 13 divided by 5. Since both these operands are both integers, 13 divided by 5 is equal to 2 remainder 3. What's going to be the evaluation of this expression is going to equal to 2. What's going to get thrown away is a 3, and that's why we're getting integer division over here. Okay, so just be aware of that. You'll more than likely make this mistake at some point in time, thinking that we're going to get true division or like floating point division when you're only going to get integer division. It's a common mistake to make. So the rule is, as long as one or both of the operands are doubles or floating point values, the evaluation of that expression will be a floating point result. So what I could do here is, right, let me go back to my IDE. So here I have a double and a double. As long as one of these, okay, is a double, the evaluation of this will be a double. So this guy here, this is a integer. This is a double, right? At least one of these is a double. So if I rerun this, I'll still get the same result, which is the 2.6. Okay, again, because I don't have two integers, I have only one. So that's how addition, subtraction, and multiplication and division work. Let me show you the one last thing is what's called modulus arithmetic. And let me do that here with modular arithmetic deals with integers. Actually, I don't think it will even work if you try to use a floating point value or a double value. And again, what modulus arithmetic will give you is the remainder of an expression. So let me use a 13 and a 5 like I have up here. All right, so here I'll have int, and let me just call this mod. Okay, and that's going to be equal to 13 mod or the percent sign 5. So what this is going to do is 13 divided by 5 is 2 remainder of 3. So the evaluation of this expression is going to return the remainder, which is going to be the value 3. Let's go down here and let's display what the evaluation of this expression is. So I'll do mod equals mod. Right. Let's see what happens when I run this. So the mod should be equal to 3 because that returns the remainder. Right. So it's not equal to 2, but it's equal to 3. that pretty much sums it up for the arithmetic operators within C++. Be careful when you do modulus arithmetic, and just be aware that it is going to just give you the remainder. I'm just out of curiosity, let me see what would happen here if I change this to be, I don't know, make it 13. I'll make this a double. Let me see if it'll complain. It does complain. So it's telling me that again, the easiest way to do this, if you double click an arrow, it'll bring you to where that is. It says a illegal FLOP operand has type double. Right? So yep, the compiler will catch this, and it will only allow me to have integers on both sides of my modulus operator. Let me explain real quick where modulus arithmetic is used, and I can give you a little example of something that we'd be able to find use for it within our class. Modular arithmetic is the part of the underlying math of security, right? So if you've ever been to a website where you type in like https:// some website or whatever, and you're sending and receiving data over a secure connection, behind the scenes, actually, modular arithmetic is used to encrypt and decrypt the data that's being sent between two endpoints. So that's one real-world example. Let me show you a little bit of a simpler example. It's something that we might use, actually probably will use in this class, and we can use modulus arithmetic to determine whether or not a number is a positive number or a negative number, or we could do something is a number within a range of 0 or 9 or something like that. So let me create a little variable here, a Boolean variable. I'll call it even. All right, so the variable even can contain either true or false. And let me create another variable, which I'm going to call just number, and I'm going to assign that the number 2. All right, and here what I'm going to do is say even is equal to number mod 2. All right. So even is going to, so the variable even is going to equal to number mod 2. So here in this case here, number is equal to 2. So 2 mod 2 is equal to 0. In that case here, it would, so if it's equal to 0, then actually kind of the logic reversed here. Even mod, let's do this. Let's do mod 3. All right, so 2 mod 3 goes in, so 2 will go into 3. How many times? It'll go into 3 0 times, remainder 2. Actually, it's still going to come up as even. Sorry, I just lost my internet connection, but it came back up now. Yeah, thinking about this, I think it would make more sense if I reversed the logic here. Let me show you why. Let me call this variable, instead of even, let me call it odd. Okay, odd. So here, odd. By the way, why am I getting this little red squiggly line here? Because I have a variable that's called odd. I'm trying to use a variable down here that's called even. This has never been defined before. Okay, so that's a common compiler error. So I'm just changing this to odd. Change this to odd. Oops, odd. And I'll change this to odd. All right. So before, why am I getting the squiggle line now? No, it goes away. All right. So let's just before I execute this, let's step through the logic here. So I have a variable that's called odd. Okay, it's bool, so it can store either true or false. Okay, I have another variable that's called number, which is assigned a value 2. And here I'm evaluating an expression which is number mod 2. So 2 mod 2 will be equal to 0, right? This is equal to 0 because there's no remainder, right? It's evenly divisible. So so this evaluates to 0, so odd will be equal to 0, or otherwise known as false. So if I do cout, odd should be equal to 0, which is an indicator that it's equal to false. So you can have logic in your program and it would say, okay, if the number is false, roll the die 3 more times, else don't roll the die again, that kind of a thing. So let me build this and run it. Let's see what we get. We're going to get another truncation warning. That's fine. We're just sticking a small integer into a Boolean variable. That's fine. Right? It's for this example, we're okay with that. So if I run this, so odd is equal to 0, right? Why? Because number 2 is even, right? So it's not odd. Let's try this again. Let me change number to be equal to, I don't know, let's make this 5. All right, so now if I do 5 mod 2, right? 5 mod 2 will because it evaluates the 2 remainder 1. So in this case here, the expression will be equal to 1, right? So we're going to store 1 in odd, which means that odd is now set to true, right? Because 5 is an odd number. So if I run this again, what do we get? Right, it says odd is equal to 1 because it's an odd number. Let's change this back to something else again. Let's make this 10 or something, right? So that's obviously not an odd number. Let me build it and compile it. So 10 mod 2, that's equal to 5 remainder 0. So 0 is going to be the value stored in odd, which is the flag which will tell us that odd is not equal to false. I'm sorry, yes, the odd is not equal to false, meaning it's an even number. So in this case here, it's an odd number, right? 0 is not an odd number. I'm sorry. 10 is not an odd number because the modulus evaluates to 0, so odd equals 0 means it's not odd, which means that it's even, right? Because 10 is in fact an even number. So that's pretty much it for the different arithmetic operators in C++. I wanted to keep this video and the screencast a little bit, about in the 45-minute range. I think that's sufficient. There are 2 little sections that I want to cover in chapter 2, and I'll do that in the next video, and that has to do with comments and name constants, and we'll continue on with chapter 3. You've probably noticed I'm trying to do the best I can to go in the order of the book. I once in a while I have to mix it up a little bit just to I think it'll maps a little bit better to our course, but I try to sort of keep the same order of the book because I feel it's more advantageous to you guys if you have something that's kind of linear that you're able to follow along with. So I'm going to post a couple labs that you'll need to work on WebStudy. Again, if you have any questions, always please let me know. And that's it for this week. Thank you. Bye bye.